Welcome to Studi.Live. In this video, we are going to talk about the mechanism of Markovnikov's rule. Yes, we have done this Markovnikov's rule in our previous class. Mechanism, we have kept it for this lecture, for this session, a separate new session. So let's start with a very brief review of what we have already done in our Markovnikov's rule. In the topic of Markovnikov's rule that already we have done, just a brief revision. What is a brief revision of Markovnikov's rule? In the Markovnikov's rule, we have said that if there is an unsymmetrical alkene and that unsymmetrical alkene reacts with an unsymmetrical reagent. Yes, so this is here CH3, CH, double bond CH2. This is your unsymmetrical alkene and this will react with unsymmetrical reagent, that is HBr. Now when this reaction takes place, there are two products to be formed. One is called as 2-bromopropane and the another is called as 1-bromopropane. This is what we have done in our previous class. This is 2-bromopropane and this is 1-bromopropane. And we have discussed that 2-bromopropane is the major product. Is given by Markovnikov's rule. So this is the major product and this is the minor. So the answer to the question why major and why minor, that is given by Markovnikov's rule. So let's start with the mechanism of Markovnikov's rule. Now in the mechanism of Markovnikov's rule, there are three different steps. We will go stepwise. The first step, that is step 1, it is the formation of an electrophile. So first step is formation of an electrophile. Now what is that electrophile? Let's make this word very clear. Electrophile. Now when I say electrophile, in case of electrophile, electro means electron, phile is loving. So species which are electron loving. So electrophiles. This is formation of an electrophile. Now how will you get an electrophile from here? So we have HBr in our reaction. So for this HBr, this is here HBr, which will give you the formation of H plus and Br minus. And now this H plus is what is the electrophile we are talking about, electron loving species. This is itself positively charged. So if this is itself positively charged, it will have the tendency to move to the electrons to join with the electron denser area. So this is the first step, that is called as formation of electrophile. Now in the formation of electrophile, as we said, this is HBr here. This HBr will undergo dissociation, a heterolytic bond fission taking place. Yes, again the terms coming up, heterolytic bond fission. Now in that heterolytic bond fission, because of the unequal distribution of electrons, gives you H plus and Br minus. And this gives you the formation of H plus, which is called as an electrophile. So this is first step, that is formation of an electrophile. This is how the electrophile forms. Now the next step, after the electrophile has formed, what is the next step now? This electrophile has to attack on the carbon-carbon double bond. So that is the next step coming up, that is attack of electrophile. So the next step, second step is attack of electrophile. Now in this attack of electrophile, now the electrophile has to attack. Electrophile has to form a bond. Where will it form a bond? It will form a bond at a carbon-carbon double bond position. So let's take the example of the alkene that we are referring to. So here the alkene is CH3, CH, double bond CH2. Now this alkene is an example of unsymmetrical alkene. Now in this unsymmetrical alkene, the most important thing you can see here is carbon-carbon double bond. Now this carbon-carbon double bond contains something called as delocalized electrons. So these are the delocalized electrons, also called as pi electrons. These delocalized electrons also termed as pi electrons. So this CH3, CH, double bond CH2 will combine with H plus. Now that's the electrophile which is going to attack. Now when this electrophile is going to attack, there are two possibilities coming up. Now what are those two possibilities coming up? Let us talk about them one by one. The first possibility that has to happen here is, now say this is a double bond, right? Now this electron can be shifted here. This is one possibility, that it is shifted at the one carbon. The another possibility is it is shifted here, a dotted one, a solid line and a dotted line. If it is shifted here, this is how it shifts here. So if it is shifting at this position, then you get the electron density over here, and this H plus joins here. Be very clear. What happened? This double bond is shifting here. Because this is shifting here, the electron of this CH will be taken away by CH2, and this becomes electron rich center. And because this becomes electron rich center, this H gets added up here. Alright, so if this is shifting here, this H will get added up here, and this will give you the formation of, yes, this will give you the formation of CH3CH. Again a revision, this gets shifted here. Because this shifting takes place, electrons are added to CH2, and because it's rich in electrons, H plus will attach here, and since H plus attaches here, this gives you a formation of CH3, and because this shifting has taken place, it gets a positive charge. Now it is getting a positive charge. Now carbon bearing a positive charge, a new concept getting added, carbon bearing a positive charge. That carbon bearing a positive charge is called as carbocation. So this forms what is called as carbocation. So this is the formation of carbocation. This is how the carbocation formation takes place. Second case carbocation, that means what happens? The dotted one I am talking about. Now see this dotted one. When this dotted one shifts here, obviously the electron density gets added over here. And if the electron density gets added at CH position, the H plus will get added here. So because of this double bond shifting at CH, electron density on CH increases. And if the electron density on CH increases, obviously H plus gets added up here. And then what you get is, you get CH3, this H getting added up here, so that is CH2, and this double bond breaks, single bond, CH2 with a plus charge. So again, this is also carbon with a plus charge, this is also carbon with a plus charge. Now when both of them are with carbon with a plus charge, they are carbocation. So this also is a carbocation. Now what is the difference between the two? The difference is the carbon bearing positive charge is attached to two other carbon atoms. So when I say carbon bearing a positive charge is attached to two other carbon atoms, then it is called as 2-degree carbocation, or you can call it as secondary carbocation. So this is secondary carbocation formation taking place. And here in the another example, here you have 1 degree or primary carbocation. This forms primary carbocation. Now coming on to the stability of carbocation, the stability of carbocation, that's also an important term that we will also see in a separate video, how stability is determined. So but for here, stability of carbocation is 3 degree greater than 2 degree greater than 1 degree. And this is accordance with inductive effect. It is in accordance with inductive effect. Now how inductive effect takes place? Now here you have got CH3 and CH3. These two groups are electron donating groups. So if they are donating electrons, you can see the arrow I am trying to show. So they are electron donating groups. Since they are electron donating groups, the charge which is present on CH will get neutralized and it will become more stable. Nevertheless, if you see here, this is only one position where it can get the charge. Now you will say, sir, one more carbon is there? No, that carbon is far away. And already we know the concept of inductive effect. As the distance increases, inductive effect decreases or intensity gets reduced. So therefore, this effect is going to be lesser. And that's the reason why we say that 3 degree greater than 2 degree greater than 1 degree. So which carbocation will be formed according to this discussion? Yes, 2 degree carbocation will be formed. And once this 2 degree carbocation is formed, now we move to the third and the last step that happens. That is, in the beginning we said HBr giving us H plus and Br minus. Already we have utilized this H plus in this reaction. What is remaining now? Br minus is remaining. And that Br minus is the third step adding. So we write here the step 3. This was your step 1. This is your step 2, that is attack of electrophile. Coming back to step 3. In your step 3, it is the attack of Br minus. In that attack of Br minus, that is bromide radical, how will this bromide radical attack? This bromide will attack in this way. See this, CH3, CH plus, and then again CH3 will combine with Br minus. So this is combining with Br minus. Now obviously this is negative charge, has to attach to the positive charge. So shifting would be something like this and will give you the formation of CH3, CH, Br, CH3. And this gives you the formation of 2-bromobutane, propane. 2-bromopropane. So this gives you the formation of 2-bromopropane. So once you get this 2-bromopropane, this is the major product. And this is what we have already said in the definition, that this will be the major product. And according to this mechanism, we have also confirmed why 2-bromopropane should be the major product. So in a quick nutshell, what we have discussed is Markovnikov's rule and its mechanism. So in the mechanism of Markovnikov's rule, first step, formation of an electrophile. Using HBr, it gives us H plus and Br minus. That's the first step. Now this H plus is an electrophile. Now this electrophile has to attack on the carbon-carbon double bond. Now when it is attacking on the carbon-carbon double bond, there are two possibilities, and that gives you 2-degree carbocation and 1-degree carbocation. According to plus I effect, we study that the stability order is 3 degree, greater than 2 degree, greater than 1 degree. And therefore 2-degree carbocation is more stable than 1 degree. And in the last step, where we say there's the attack of Br minus, in the attack of Br minus, this Br minus gets attached to CH and gives you the formation of 2-bromopropane. This is 2-bromopropane, which is formed as the final product, as the major product. So this is all about the Markovnikov's rule and its mechanism. So in the upcoming videos, we'll be talking about more such mechanisms. Stay tuned with Studi.Live. Thank you, students.